When we are given a quadratic equation that's in standard form, we must remember that it is y equals ax squared plus bx plus c. So in the example we have here, we will have y equals x squared plus 6x plus 9. Our goal is to redraw this using algebra tiles. So with that being said, we want to make sure that we bring out an x squared for the x squared. We have 6 x's, so we are going to bring out 6 different x's, and we have a unit of 9. So we are going to bring out 9 individual ones. With this creation, our goal is to create a square, hence completing the square. So with that, we can start to move around these x's and these x squareds till we have a square. And we can see how these work all together, and all of the side lengths are exactly the same. Now that we have the algebra tiles all rearranged into our square, we can see that the side lengths are the same. We can see that this x squared was only received and gotten by getting an x times an x, similar to a Punnett square in biology. Since we have an x squared with that x and x, that starts to give us a feeder into our other pieces. So right here we have x times something was x. That would be a 1. X times something was x, that's 1. And x times something is x, that's 1. So what we really see here is on the side, it's really x plus 3. Repeating the process on the other side, we see x times 1 was x times 1 gives you x, and x times 1 gives you x. And sure enough, just as we stated before, this is also a plus 3, making the side lengths of this, a square, the same. Finally, if we multiply this 3 and the 3 here, we can see that in the bottom right box, it creates 9, which 3 squared gives you 9. So all in all, we see the area of this square is received by getting the side length x plus 3 times the other side length of x plus 3, written a little bit more simply as x plus 3 quantity squared. Taking a look at our visual square and the now vertex form of the quadratic equation, do you notice any patterns of our factors compared to our b value? Our factors are x plus 3 and x plus 3, and our b value is 6. Well, what about the units that are in the square compared to the b value? We see in here their units are 9. How does that compare to the 6? It appears that to go from our b value to our factors, that the b value is split in half. We can see 6 x's, or 6 is split 3 here and 3 here. And the final block seems to be the b value cut in half and squared. So a couple things to look out for here is, given our b value, we will sometimes cut it in half, and also given our b value, we will cut it in half and square it. Comparing it to our factors, it appears to be x plus half of b squared. Now that you've seen an example, let's try and work one all the way through. Our new example is y equals x squared plus 2x plus 1. We can start by identifying the b value of the quadratic equation. Given ax squared plus bx plus c, it is clear that the b value is 2. From the previous example, we want to create a square by splitting this b value into 2 equal pieces. So we have an x squared. We will bring that out. We have 2 x's. So if we split that, 1 goes on the right, 1 goes on the bottom. And then finally, we can see the 1 unit is going to fit in the bottom right. Similar to what we did before, we can see that in order to get x squared, that is x times x, in order to get x times something to x, that's plus 1, and x times something to x is plus 1, and finally, 1 times 1 is 1. We work through this exactly like you would see a Punnett square. So when we look at this, we should notice if our b value is 2, half of 2 is equal to 1. That is received by b over 2. From there, we can take half of b and we can square it. So that's 2 over 2, which is 1, squared is 1. So we see that the x here and the x here, those side lengths are from half of b. We see the bottom right square here is half of b squared. Finally, we can write this in vertex form by writing the form x plus half of b quantity squared. So we see here y equals x plus, we have half of b is 1, so it's x plus 1 quantity squared, which matches the side lengths of our visual.